and happy Monday morning. Today, let's see, the message, here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today, eventually, we're going to go on and cover section 9.5. Tonight's assignment will be section 9.5 as well as the chapter review. Just a reminder, tomorrow is advising day, so there won't be any Zoom meetings, no class, no office hour. Wednesday, we will review for the chapter 9 test, and then on Thursday, again, there'll be no class meeting. You'll just take your test sometime Thursday. And of course, you can always take it early, but once you open it, the timer starts. Okay, so now what I want to do is I have some requests from section 9.4. So let's take a look. This is from 9.4, number 16, and you should see that on the left side of the screen in WebAssign. It says, multiply and simplify. The variable represents a positive real number. Therefore, we don't need to worry about absolute value bars. So we have -3 times the square root of 7x, and then parentheses, 4 times the square root of 3x minus 5 times the square root of 5. So distributing, we get -3 square roots of 7x times 4 square roots of 3x, and then negative times a minus is plus 3 square roots of 7x times 5 square roots of 5. Again, I used up these two signs to get that. Okay, so now what do we have here? We have -12 square roots of 21x squared plus 15 square roots of 35x. However, in this first term, the square root of x squared is x outside, so we get that. The second term, there are no perfect square factors inside, so there's our final answer. And I notice that WebAssign has it written this way. It shouldn't matter either way. That negative sign is attached to the whole thing or to the 12. It would look the same. So this way or like that. Okay, let's take a look now at number 20. So this again is in 9.4, number 20. Multiply and simplify. We have 3 times the cube root of 9 minus 4 times the cube root of 3, all being multiplied by 4 cube roots of 9 plus 3 cube roots of 15. So we're multiplying, if you will, a binomial times a binomial. So we're going to FOIL it, okay? So we're going to take this times this, which is going to give us 3 cube roots of 9 times 4 cube roots of 9, and then this, which is plus 3 cube roots of 9 times 3 cube roots of 15 minus 4 cube roots of 3 times 4 cube roots of 9 minus 4 cube roots of 3 times 3 cube roots of 15. So now we've got 4 products. Let's take a look at each one. So this first one, we get 12 cube roots of, and here's what I'm going to do, okay? 9 is 3 times 3, so this would be 3 squared. 9 is 3 times 3, so this would be 3 squared. So that would be 3 to the 4th power, but I'm going to write it as 3 cubed times 3, okay? So now I've got 12 times the cube root of 3 cubed, and then times the cube root of 3, which is 36 cube roots of 3. Okay, so there's one of the terms. Next group, plus 9, and this is going to be the cube root of 9, which is 3 times 3, 15, which is 3 times 5, so I got 3 cubed times 5, okay, which is plus 9 times cube root of 3 cubed is 3, and then cube roots of 5, so plus 27 cube roots of 5. Okay. Here we've got minus 16 cube roots of, this is a 3, this is 3 squared, so 3 cubed, which is minus 16 times the cube root of 3 cubed, which is 3, so minus 48. And then finally, 12, and then we've got the cube root of 3 times 5. Nothing's going to come out of there, so minus 12 cube roots of 45. Again, minus 12 cube roots of 45. And none of those are like terms, so there's our final answer. All right. We've got another student's request, so we're going to stop the sharing and we'll go to this screen only. And let's see here. Okay, let's see here. 14. All right, we'll go back and share this screen. These are again questions from section 9.4. Let's see here. This is number 13. Multiply and simplify. The variable represents a positive real number. So once again, we don't need absolute value bars. Okay. Now, we've got the 4th root of 7a cubed times the 4th root of 343a squared. Okay. Which would be the 4th root of 7 times 343 times 8 to the 5th. Okay, let's see. 343 is 3 times, let's see. Oh, 3 doesn't go in there, does it? What does go in? How about, let's try 7. Let's see. 343 divided by 7, 49, yeah. So this is 7 times 49, 7 times 7 times 7. Why did I think 7? Just because that was there. So I thought, that's probably what they're doing. So this is the 4th root of 7 to the 4th power. Because here's a 7, and then here's 7 cubed, times a to the 4th times a. So a to the 5th, I break it down to a to the 4th times a. Again, I'm looking to match my index with my exponents. So the 4th root of 7 to the 4th is 7. The 4th root of a to the 4th is a, and I've got the 4th root of a left inside. Final answer, 7a, 4th root of a. Okay. Let's take a look at number 16. We've got -5 square roots of 7x times 2 square roots of 5x, 5x, square roots of 5x minus 6 square roots of 6. Okay, so distributing, I get -5 square root of 7x times 2 square roots of 5x. And then minus times minus is plus 5 square roots of 7x times 6 square roots of 6. Let's see here. In this first one, I get -10 square roots of 35x. And there's no perfect square factors there. And then plus 30 square roots of 42x. Again, no perfect square factors there. So that's my final answer. Okay, takes us to number 17. Multiply and simplify the cube root of 9 times 81 cube roots of 81 plus the cube root of 243. So distributing, I get the cube root of 9 times 81 cube roots of 81 plus the cube root of 9 times the cube root of 243. Okay, let's see here. Well, 81 is 9 times 9. So if I put those together, I'm going to get 81 times the cube root of 9 times 9 squared, which is 9 cubed. Okay, so I get 81 times the cube root of 9 cubed, which is 9, and this is 729. Second group here. Let's see, 243 is 3 times 81 is 3 times 9 times 9. So this would be the cube root of 9 times the cube root of 3 times 9 squared, which would be the cube root of 9 cubed times 3, 9, 9, 9, okay, and then a 3. So that's going to be 9 cube roots of 3. So 729 plus 9 cube roots of 3 would be the final answer. All righty. Let's take a look at problem number 19. Multiply and simplify the square root of 5x minus the square root of 3y times the square root of 5x plus the square root of 3y. That's a conjugate pair. We have the difference of two numbers times the sum of the same two numbers in the same order. So when we FOIL it, the middle two terms are going to cancel out. Let's see, we've got the square root of 5x times the square root of 5x plus the square root of 5x times the square root of 3y minus the square root of 5x times the square root of 3y minus the square root of 3y times the square root of 3y. So we get 5x and then what? Plus the square root of 15xy minus the square root of 15xy minus 3y. Those two terms cancel out. 5x minus 3y. Final answer. Okay. Number 20 coming up. Multiply and simplify. Cube root, 3 times the cube root of 9 minus 3 times the cube root of 3, all times 3 times the cube root of 9 plus 3 times the cube root of 15. This is not that difference of two squares. It starts, it looks like it at the beginning, but that 15 under the last radical messes it up. So what do we got here? We've got 3 cube roots of 9 times 3 cube roots of 9 plus 3 cube roots of 9 times 3 cube roots of 15 minus 3 cube roots of 3 times 3 cube roots of 9 minus 9. Hang on. I shouldn't multiply that together first. Come back to do that. Okay. Minus 3 cube roots of 3 times 3 cube roots of 15. Okay, now we'll go back and multiply each thing together. This is 9 cube roots of 9 is 3 times 3, and this is 9 is 3 times 3, so that's 3 to the 4th power, or 3 to the 3rd times 3. So I get 9 times the cube root of 3 cubed is 3, and then that's left inside. So 27 cube roots of 3. Okay. Here we get plus 9. And this is what? The cube root of 3 times 3 times 3 times 5. 15 is 3 times 5, so 3 cubed times 5. So we get plus 9 times 3. The cube root of 3 cubed is 3. Cube root of 5, so plus 27 cube roots of 5. And then here, minus 9, cube root of 3, and then 9 is 3 times 3, so that's 3 cubed. So we get minus 9 times 3, or minus 27. And finally here, minus 9, and then we've got the cube root of 3 times 3 times 5, so just minus 9 cube roots of 45, minus 9 cube roots of 45. And there's your final answer. So what are we doing? We're trying to build cubes. So we're taking, numbers like this, 15, breaking it down to 3 times 5, 9 is 3 times 3. So there's 3 times 3 times 3, which is 3 cubed, that kind of idea. Okay, let's see, how are we doing for time? We're still okay. This is, where's my nose? Here it is. 9.4, number 21. And we've got the cube root of 7z plus the cube root of 2 times the cube root of 7z plus 9 cube roots of 2. So again, we're going to FOIL things together, and we're going to get the cube root of 7z times the cube root of 7z plus the cube root of 7z times 9 cube roots of 2 plus 3 cube roots of 2 times the cube root of 7z plus the cube root of 2 times 9 cube roots of 2. Okay. Well, the first product, there's no cubes there, so we're just going to get the cube root of 49z squared. Same thing here, next one, plus the cube root of 14z plus the cube root of 14z. Hang on a second. Did I copy everything right? 2. Something tells me I miscopied this. 9. I'm going to pause this recording. See if I can find out. All right, I found my mistake. Right here, I left out that 9. So that should be 9 squared to 14z. And then we get, finally over here, plus 9 cube root of 4. Interesting. I'm looking at the answer that the author has, but these two terms are like terms. So actually, I don't think this answer is correct either. I think your final answer would be the cube root of 49z squared plus 10 cube roots of 14z plus 9 cube roots of 4. If you see something that you think I made a mistake on, email me and we'll talk about it. Okay, but I think that's the final answer there. All right, yeah, because it looks to me, these two terms right here, oops, come on, it won't let me highlight it. Anyway, those should be like terms. Okay, that takes us to number 27. And I'm gonna once again make sure I've got this recording and I'm sharing the right screen. 27. Lots of questions today, but fortunately there's no one here, so I can just keep going and take however long I need. All right, we have the square root of 2x plus the square root of 2 squared. So basically that's the square root of 2x plus the square root of 2 times the square root of 2x plus the square root of 2, which is the square root of 2x times the square root of 2x plus the square root of 2x times the square root of 2 plus the square root of 2 times the square root of 2x plus the square root of 2 times the square root of 2. Yeah, let's clean that up a little bit. There. Okay, so this is going to be 2x. This is going to be 2 square roots of x, because the square root of 2 and the square root of 2 makes the square root of 4, which is 2 outside. This is going to be 2x, and this is going to be 2. So 2x. Ah, I see my sloppiness here. So apparently I need to slow down. Okay, that's 27. We've got 4 more to go, and then we will get to today's lesson, believe it or not. Rationalize the denominator. Okay, so I've got 29 divided by the square root of 75p to the 5th, which is 29 over the square root of 25 times 3 times p to the 4th times p, which is 29 over 5 p squared square root of 3p. So I've simplified the denominator. Now I'm going to multiply the top and the bottom by the square root of 3p. So I get 29 square roots of 3p over 5p squared times 3p, which is 29 square root of 3p over 15p cubed. And nothing can further reduce. So there's the final answer there. Okay. (34) 7 over the square root of 40b cubed. Again, rationalize the denominator. It says the variable represents a positive real number. So this is 7 over the square root of, let's see, 4 times 10 times b squared times b, which is 7 over the square root of 2b square roots of 10b. Multiply the top and the bottom by the square root of 10b. We get 7 square roots of 10b over 2b times 10b, which is 7 square roots of 10b over 20b squared. And nothing will reduce there. So there's the final answer. And then we've got 36 and 37, and then we'll get started on today's lesson. Okay. I know, lots of questions, but my guess is you probably had lots of questions, all of you. Perform the operations and simplify if possible. All variables represent positive real numbers. -8 cube roots of 9 r squared s times 9 cube root of 2r. Well, that would be -72 cube root of, let's see, 18 r cubed s. Okay. Now, 18 is 2 times 3 times 3, no cubes there. S, no cubes there, but there's a cube here. So I'm going to get negative 72 r coming outside cube root of 18s. So that's the final answer there. And one more, 37. Okay, 2 square roots of 5r minus 5, the quantity squared, is 2 square roots of 5r minus 5 times 2 square roots of 5r minus 5, which is 2 square roots of 5r times 2 square roots of 5r minus 5 times 2 square roots of 5r minus 5 times 2 square roots of 5r, and then plus 25. So I get 2 times 5r, or 10r, minus 10 square roots of 5r minus 10 square roots of 5r plus 25, which is minus 20 square roots of 5r plus 25. So I get that should be a 4. Again, haste makes waste. That's what I get for trying to do all these problems. Okay. So this was a 2, this is a 4, and this is a 20. So we've got 20r minus 20 square roots of 5r plus 25. So the lesson you can get from me is to slow down. Okay, hang on. I'm going to go back to our regular screen. So give me just a minute here. Okay. All right, now let's take a look here. So now we're going to get started, believe it or not. This is section 9.5. All right. So last chapter, chapter 8, we dealt with absolute value equations. And one of the rules was if you have an equation with a single absolute value, isolate that absolute value term first. If you have an equation with 2 of them, separate them. We're going to deal with radical equations, and we have the same rules. If it contains 1 radical, we want to isolate that. If it contains 2 radicals, we want to separate them. Let's take a look at a problem. Here we go. So let's say we've got the square root of x minus 10 equals 1. This equation has 1 radical term. It's already isolated. We have the square root of the quantity x minus 10 equals 1. Okay. So what we're going to do now is we're going to square both sides of the equation. On the left side, we get x minus 10. On the right side, we get 1 squared, or 1. Going on and solving for x, we'll add 10 to both sides, and we get x equals 11. Let's check our work. If we put 11 in the place of x in our original equation, we get this, which is this, which is this, which checks. So x equals 11 is a correct solution. All right, let's take a look at another example. The square root of the quantity 5x minus 6 equals 2. We have a single radical in the equation. It's already isolated. So now we're going to square both sides of the equation. The square root of 5x minus 6, the quantity squared, is 5x minus 6. And on the right side, 2 squared is 4. So we'll add 6 to both sides. 5x equals 10. Divide both sides by 5. X equals 2. Let's check our work. We're going to put a 2 in the place of x. And we get the correct solution. Or it checks also, 2 equals 2. This doesn't always have to be the same number as the solution, but in this case, it turned out that way. Okay, let's take a look at one with a fraction. 1/2 x plus 3. Square root of that equals 6. Once again, the radical is isolated. We'll square both sides. We get 1/2 x plus 3 equals 36. Subtract 3 from both sides. 1/2 x equals 33. Multiply both sides by 2. X equals 66. And again, let's check our work. 1/2 times 66 is 33. 33 plus 3 is 36. The square root of 36 is 6. 6 equals 6. So the solution checks. Okay, now, this idea of squaring both sides of the equation is great, but sometimes it produces answers that don't work. Those answers are called extraneous solutions. Extraneous solutions. Those are solutions that we get, but in fact, they don't work. And in WebAssign, be careful of the instructions. It will ask you sometimes whether a solution is extraneous or not, meaning it doesn't work. Okay, so take a look at this problem. We have the square root of 2a minus 3 plus 3 equals a. So we now have an equation that has one radical, but it isn't isolated yet. So our first move is to subtract 3 from both sides of the equation. Okay, so now I've got that. Next, I have to square both entire sides. Now be careful, over on the right, I don't do that, okay? It's not a squared minus 3 squared, it's a minus 3, the quantity squared. So on the left side, I get 2a minus 3. On the right side, foiling together, I get a squared minus 3a plus 9, which is a squared minus 6a plus 9. So I've got 2a minus 3 equals a squared minus 6a plus 9. Okay. This is a second degree equation. So let's take advantage of what we learned in chapter 6. We'll set it equal to 0 and then see if we can factor it. So I'm going to subtract 2a from both sides and add 3 to both sides. I get 0 equals a squared minus 8a plus 12. And that factors into, let's see, minus 6 and minus 2. That's an a. My a's look like 9s. Sorry about that. Still does. A minus 6, a minus 2. Okay, so if a minus 6 equals 0, a minus 2 equals 0, add 6, a equals 6, add 2, a equals 2. So these are potential solutions, okay? Now, I've run out of room here, so I'm going to go to the next page and I'm going to recopy the original equation. Okay. Square root of 2a minus 3 plus 3 equals a. And then I've got a is 6 and a is 2. So a is 6, a is 2. Let's check those. If a is 6, 2 times 6 minus 3 plus 3 equals 6. Square root of 12 minus 3 plus 3 equals 6. Square root of 9 plus 3 equals 6. 3 plus 3 equals 6. 6 equals 6. So this one checks. Now let's take a equals 2. The square root of 2 times 2 minus 3 plus 3 equals 2. The square root of 4 minus 3 plus 3 equals 2. the square root of 1 plus 3 equals 2. 1 plus 3 equals 2, 4 equals 2. No, so 6 is a solution, 2 is extraneous, doesn't work. All right. Let's see here. How about this one? The square root of 3x plus 5 equals 2. Solve each equation, write all proposed solutions, cross out those that are extraneous. So again, I've got to isolate the radical. So I'll subtract 5 from both sides of the equation. The square root of 3x equals -3. Then I will square both sides. 3x equals 9, -3, the quantity squared. -3 times -3, +9. Divide both sides by 3, x equals 3. Let's check our work. Square root of 9 plus 5 equals 2. 3 plus 5 equals 2. 8 equals 2. No, so this is not a solution or no solution. And this would be an extraneous solution. Okay, now this particular problem, if you were awake, you could see that there was going to be no solution. At this point right here, when I had the square root of 3x equals -3, remember, taking an even root, you can't get a negative answer. So already I could see that that wasn't going to work. But if they ask you to find extraneous solutions, you know, find the solutions and then label them, you'd have to go on and look for this. Okay. Now, what about this situation? The cube root of 12m plus 4 equals 4. So now, instead of squaring both sides, I'm going to cube both sides. Again, the radical has already been isolated. So I've got 12m plus 4 equals 4 times 4 is 16 times 4 is 64. Okay. Subtract 4 from both sides. 12m equals 60. Divide by 12. M equals 5. Let's check our work. Cube root of 60 plus 4. Cube root of 64. Cube root of 64 is 4. 4 equals 4. So that checks. Okay. Let's see here. What about this situation? You've got, Let's see here. We've got x cubed plus 56 to the 1/3 power equals x plus 2. So what are we going to do with this? We're going to cube both sides. And that's going to be horrendous on the right side, isn't it? Yeah, I was hesitating. Do I really want to do that? But I thought, why not? So on the left side, we get x cubed plus 56. On the right side, we've got x plus 2 times x plus 2 times x plus 2. So we're going to do the first 2 first, which is going to give us x squared plus 2x plus 2x plus 4 times x plus 2, which is x squared plus 4x plus 4 times x plus 2, which is now x cubed plus 2x squared plus 4x squared plus 8x plus 4x plus 8, which is x cubed plus 6x squared plus 12x plus 8. And all of that's going to go up here, giving us this. X cubed plus 56 equals x cubed plus 6x squared plus 12x plus 8. Fortunately, you can stop this video and back it up if you need to. This is a third degree equation, but if I subtract x cubed from both sides, I get 56 equals 6x squared plus 12x plus 8. So now it's a second degree equation. I'm going to subtract 56 from both sides, and I get 0 equals 6x squared plus 12x. Let's see, minus 48. Oh, I could factor a 6 out of that and get x squared plus 2x minus 8, which is 6 times, let's see, I'm going to have a plus 4 to minus 2. So then x plus 4 equals 0, x minus 2 equals 0. This is like a review of everything we've done this quarter, it seems like, just about. Subtract 4 from both sides, x is negative 4. Add 2 to both sides, x is 2. Let's take this original equation, recopy it on the next page, and check our answers. So I get x cubed plus 56 to the 1/3 power equals x plus 2. And we're going to use x is negative 4, x is 2. Okay, let's take the 2. This is going to be 2 cubed plus 56 to the 1/3 power equals 2 plus 2. 8 plus 56 to the 1/3 power equals 4. 64 to the 1/3 power equals 4. 4 equals 4. So this one checks. Negative 4. Negative 4 cubed plus 56 to the 1/3 power equals negative 4 plus 2. Negative 64 plus 56 to the 1/3 power equals negative 2. Negative 8 to the 1/3 power equals negative 2. Well, the cube root of negative 8 is negative 2. Negative 2 equals negative 2. So they both check. All righty. Now, let's take a look at this one. It says, let f of x equal the cube root of the quantity 3x minus 6 for what value or values of x is f of x equal to negative 3. So we're going to substitute. We're going to take negative 3 and not put it in place of x, but put it in place of f of x. So now we get this equation. The cube root, the radical, is already isolated. We'll come back and we'll cube both sides, and we get negative 27 equals 3x minus 6. So solving for x, we'll add 6 to both sides, and we get, hang on here, 6. We get what? Negative 21 equals 3x. Divide by 3, x equals negative 7. Let's check our work. Negative 3 equals the cube root of 3 times negative 7 minus 6. Let's see. That's going to be negative 3 equals the cube root of negative 21 minus 6. Negative 3 equals the cube root of negative 27. Negative 3 equals negative 3. It checks, and all is good with the world once again. How about one where we've got 2 radicals? As I mentioned earlier, when we have 2 radicals, we want them on separate sides of the equation. So we're going to square both sides. We get m plus 4 equals 2m minus 5. I'm going to solve for m on the right. 4 equals m minus 5. Add 5 to both sides. M equals 9. Let's check our work. So we get the square root of 13 equals the square root of 18 minus 5. Square root of 13 equals the square root of 13. That checks. M equals 9 checks. Okay. Now, let's see here. We're going to solve some formulas involving roots. So we have this following formula. It says d equals 1.4 square root of h, and we're to solve for h. So there's a couple of different ways we can do this. We can isolate the radical, or we can just leave it where it is now. The 1.4 is still part of the same term. So when I say isolate the radical, before you do anything, you need to isolate the radical term. So let me show you both ways. I can do it like it is, and I'll square both sides, and I get d squared equals 1.4 squared square root of h squared, which is d squared equals 1.96 h. Then I could come back and divide both sides by 1.96, and I get h equals d squared over 1.96. I can also do it this way. Divide both sides by 1.4 to start with, and then square both sides, and I get d squared over 1.96 equals h. But this whole term has a radical in it. So I don't have to isolate just the radical part, but I have to make sure I have just one radical term. Okay. Let's see. How about this one? D equals the cube root of 12v divided by pi, and we're to solve for v. So the radical's already isolated. I'll cube both sides. I get d cubed equals 12v over pi. My v looks like an r. Then we'll multiply both sides by pi. So we get pi d cubed equals 12v. Divide both sides by 12, and v equals pi d cubed over 12. Let's see here. Let's do this one. R equals the cube root of a divided by p, and then minus 1. And the minus 1 is outside of the radical. We're going to solve for p. So the first thing we're going to do is add 1 to both sides. R plus 1 equals the cube root of a over p. Then we'll cube both sides. R plus 1 cubed equals a over p. Now, the first time I did this problem, I went ahead and took r plus 1 times r plus 1 times r plus 1. To find out the author didn't do that. I guess we don't need to in this case. Back here a ways, let's see, where was it? There was one where this thing here, because it was all in the one variable x, we had to go ahead and cube that whole thing out to solve it, but we don't need to do that here. I'm trying to solve for p, but p is in the bottom and I need p on top. So we'll do that, which gives me p times r plus 1 cubed equals a. Now I'll divide by r plus 1 cubed, and I get p equals a over r plus 1 cubed. Okay. Let's see. I'm going to do one more, and then we'll call it good. This says, let f of x equal the fourth root of x plus 8 minus the fourth root of 2x. Find all values of x for which f of x equals 0. So again, we're going to substitute. We're going to put 0 in the place of f of x. So that's going to give me this equation. Oops. I've got two radicals, so I want to isolate them. So I'm going to add the fourth root of 2x to both sides. So now I've got this. I've got the fourth root of 2x equals the fourth root of x plus 8. I'm going to raise both sides to the fourth power, and I'll get that. Subtract x, I get x equals 8. Let's check our work. 0 equals the fourth root of 8 plus 8 minus the fourth root of 2 times 8. 0 equals the fourth root of 16 minus the fourth root of 16. 0 equals 2 minus 2. 0 equals 0. It checks. Okay, we made it, and I only went over by 2 minutes. I know that was kind of fast, but again, you can always stop the video and go back and look. So tomorrow, again, advising day, no class. I will be back today at 1:15 with an office hour, and then I'll be back on Wednesday with regular class time at 11:30. But tomorrow, no class, no office hour. And with that, we'll stop the recording.